The actual death of the 4.7T system was really, there was really two factors. Firstly, we didn't get continued funding from the Wellcome Trust, but we did get guidance that they wanted us to do more clinical-based research. But also, at the same time, the magnet quenched. It quenched over Christmas, it lost all its helium, and it would have cost something like £50,000 to bring it back up to field, and we simply didn't have that money to spend for that purpose. So we decided to call it a day there and spend all our efforts to try and get a new 3T system, which we've done. The 3.0 Tesla machine we accepted in August, and so it's a relatively new machine. It's top of the line. We're waiting for a 32-channel head coil, which will improve the performance dramatically. The multiple-channel receiver coils are a very exciting development. Essentially what it means is that the coil is broken down into a number of elements. We're looking forward to getting a 32-channel coil, and that will have 32 separate receiver channels, and the signal can be measured from each of those. The first improvement it gives you is more signal-to-noise ratio, because the closer you can get your receiver coil to the brain, the larger the signal that you can measure. And you can put these all around the brain very closely and get a huge signal. So the improvement is about a factor of 3 on the outside of the brain, going down to about a factor of 1.5 in the center of the brain in terms of signal-to-noise ratio. But also, you have the information that these coils are more localized and see local parts of the brain. So that means that you can actually do away with some of the encoding steps that you need to produce an image, which means you can shorten the imaging experiment, and shortening the imaging experiment reduces the distortions, particularly the susceptibility distortions that we see at the frontal part of the brain. So I think the parallel imaging in combination with these new coils could have some terrific benefits for functional MRI, not least of which removing some of these horrible susceptibility dropouts and reducing the distortion in the brain through reducing the length of the imaging experiment.